Hello all of you guys, welcome to review presentation of RIP 2. Now RIP will introduce to you research about an ANN-based optimization model for facility layout problem using simulation technique. It's written by Azimi and Sophie. Firstly, I am honored to come with the first best is introduction. The objective of this research is to find the optimal layout in today's manufacturing system and evaluate the most appropriate handling transporter in terms of considering material handling cost and completion time of job. The author first defined the problem statement of this work as the lack of parallel engineering in selecting the material handling system with respect to the facility layout is lead to a high degree of disharmony between the facility layout and material handling system. Through this study, the researcher needs to deal with the limitation of real-world situations that the manufacturing is facing that could affect the result of work, such as stochastic process time, random breakdown, and cross-check among transporters. And now I will show you some related work that researchers showed and reference. After learning the pros and cons of the study, the author brings a very new optimization approach for handling impression and nonlinearity of layout problem in some special case of a manufacturing system by integrating simulation, ANN, and HGA2. So now my friend will continue to deep dive into this paper detailed problem.
Now let's move to the next part, which is problem description of the research. As you can see, a design for the system requires an arrangement of M machines in M predefined position and assign a transporter to each pair of machines in order to both material handling cost and max pain are minimized. The next slide, before setting the objective and constraint for the research, we need to understand the index and parameter first, and these are shown in the picture in the screen. The next slide, as mentioned above, we want to minimize both material handling cost and max pain. So there are two objective functions are set. As you can see from the objective function number one, the problem is related to minimize material handling cost, which is calculated by reducing all the variable assigned into facility layout, multiple width, cost, and distance. Moreover, in objective function number two, show the minimization of max pain that is evaluated by ANN method. To solve the two-main objective function, there are seven constraints are set in order to solve the problem. Constraint number 3 and number 4 are to assign each machine into one location in order to make sure that each location has only one machine. From the constraint number 5 to 7, allocate the transporter for movement between two machines and they just work when material flow exists. The last constraint 8 and 9 are to make sure that the transporter cannot exceed maximum number of transporter. The next interesting part I want to share with you is ANN method. As you can see from the figure 2, a series of different scenarios are generated. Then based on this scenario, this red event simulation model is run. This input-output data is used to train an ANN to approximate the objective function. After that, we take the output from ANN in order to evaluate the fitness. If it is suitable, then we optimize it. If it's not, we need to use ANN method again. Let's talk about ANN techniques. As you can see from the figure 3, the inputs of ANN method are location of the machine and transporter allocations. For example, the location machine 1 and 2 are in location 3 and 1 respectively. Corresponding to machines, transporter number 1 will be allocated there. The output of ANN model is the max pain. Regarding to the process of ANN, each single neuron takes an input and perforated by synapses this way. Then, through adder, a special value pi b is added to the signals to generate the value u. Finally, activation function transfers the value u to the output, which is max pain. In the next part, my friend will tell you.
Now we come to the NSGA2 section. NSGA2 is one of the multi-objective algorithms that exhibit high performance and has been widely applied in various disciplines. The algorithm makes use of the fast non-nominated shortening approach to select good solutions and eliminate bad solutions from the population. Next slide, we come to non-nominated shortening. Before selection is performed, every individual in the population is assigned a rank based on non-nomination, and we can see each step in the slide. After define the rank, we have another metric to evaluate the solution of the same non-nominated front is the crowding distance, which is defined as the picture in the slide. Thus, if two individuals have the same rank, the one with the larger crowding distance is the better. Next slide, we come to adaptive local search scheme. The HNSG2 represent in this article use adaptive simulated annealing algorithm at the local search because of its good conversion rate. The local search operator have to intensify the search in various areas. First, we compute the similarity coefficient for each pair of chromosome, as we can see in the picture. And then next slide, we calculate the average similarity coefficient of the population, in which n is the number of chromosomes in the population. And finally, we considering the predefined threshold similarity coefficient phi and obtain average similarity coefficient. The local search scheme will be automatically incorporated into the NSG2 loop as follows. Next slide, we talk about the chromosome structure. The proposed chromosome consists of two matrices. The first part shows how machines are placed in the location, and the second part represents the allocation of the transporter to each pair of machine. Figure 5 shows in which machine 1 is placed in the location 1, machine 3 is placed in the location 2. The material between machine 1 and machine 2 are moved by transporter 1, between 1 and 3 are moved by transporter 4, and so on. And next slide, we come to crossover operator. The search for the best solution depends mainly on the creation of new individual from the old one. The process of crossover ensures the exchange of the genetic material between parents and thus create chromosomes that are more likely to be better than the parents. The crossover operator combines two chromosomes to produce a new chromosome. We apply two crossover tasks that only generate feasible solution, and we can see that in the slide. Then we come to the mutation. In this paper, the mutation operation is performed only on the machine layer matrix. First, a chromosome is randomly selected. Then, to create a hard chain, the chains of selected chromosomes are arranged inversely. And now we talk about the neighborhood structure. Two-string neighborhood is used to define the neighborhood in the local search algorithm. First, we select a submatrix randomly. Then, two different cells are selected randomly, and the number in these cells are a string. Figure 9 shows a neighborhood in which submatrix 1 changes in chains 2 and 4. The next slide we talk about Kuhn-Lin schedule. A practical simulated annealing implementation requires generating a finite sequence of decreasing value of temperature T and a finite number L of state transition for each temperature value. To achieve this a Kuhn-Lin schedule must be specified. And with the formula we can see in the slide, where alpha is the Kuhn-Lin rate and is obtained by some experiments. And finally, we move to the last part is stopping criterion. To limit the number of replication of both NSG2 and SA algorithm, some convergence experiments are performed, and the best criterion is applied as follows. First, we define the set of M iteration as a RAL. And then for outer loop of the SA, with a certain number of iteration is set as the stopping criterion. And then my friend will represent the next part.
The next part is computational experiment are accomplished in three phases. In the first phase, the validate the simulation model through real data analysis, and in the second phase, an ANN is developed and its accuracy in predicting the max band is investigated. In the last phase, a comparison between HNSG2 and normal NSG2 is presented. Now let's turn to the next session. In this session, the simulation model behaves will investigate in accordance with the actual system or not. The simulation result of 30 days are compared with the actual measurement data in terms of max band for each day. As presented in the table, there is an error less than 2% showing high accuracy of the desired simulation model. Let's talk about the case study of the research. This case study involves 6 machines named machine 1, 2, 3, 4, 5, and 6 with 6 products. The demand of product is shown in the table 1, so the material flow between machines is clear. The distance between location and capacity and speed of the available transporter are respectively shown in the table 2 and table 3. After that, a set of proper scenarios are selected for the proposed simulation model to generate training data. Then a new neural network is trained using this data set, or experiments is generated by uniform design shown in the picture on in the screen. And the author also present problem has 16 control factors as the input neurons and the max pain as the single output. Therefore, an ANN includes 16 input nodes and one output node. The number of nodes in the hidden layer can be estimated by the formula 14, and the result of this formula is 14 nodes. The next line is for intercomparison between the simulation and measure max pain using ANN model. First, two performance measures such as the root mean square error and the coefficient of determination are used as the formula follow. According to these two measures, the ANN model has been properly trained and has a good quality prediction. In the figure 11, in each experimental trial, the predicted result by ANN rest points fall within the interval obtained by the simulation, so the capabilities of ANN was proven. In the last session, the performance of HNHEA2 was analyzed by comparing the Pareto funds with those obtained by common NHEA2 in terms of metric Pareto ratio, which is called PR, spacing as overall Pareto split OPS, and computational time CPU time. The explored bound and optimum level of each parameter are presented in the table on the screen. The figure 12 and figure 13 present the result of the proposed HNHEA2 and the original NHEA2 in the context of material handling cost and max pain. In the figure 12 show the material handling cost index. You can see HNHEA2 outperforms original NHEA2 in all the text problems except for P6. Meanwhile, the max pain show HNHEA2 find better result than NHEA2 in all problems except for P5 in the figure 13. We also analyzed the performance of algorithm using statistical tests. As you can see, the hypothesis is that mu1 is obtained average value by HNHEA2 and mu2 is obtained value by NHEA2 algorithm. According to table 7, it can be seen that in terms of PR and CPU times index, there is no meaning difference between algorithms, but HNHEA2 outperforms NHEA2 with respect to spacing and OPS metrics. According to mean statistics, it can be claimed that HNHEA2 is relatively faster than original NHEA2. In conclusion, the proposed approach integrates computer simulation, ANN, and HEA2 techniques. It has to overcome the limitation of traditional layout optimization method. Moreover, author also showed some future work. Thank you for listening.